Okay, so in this video, we're going to take a look at one of the first algorithms that's implemented in NashPy for calculating Nash equilibria. So what we have here is a 2x3 game. So the role player has 2 strategies and the column player has 3. And note here, compared to other videos where I have just used list of lists for my payoff matrices, here I'm creating NumPy arrays, and it makes no difference to NashPy. It handles those in the same way. So what we can do once we've done that is create our equilibria. So once we've defined our game, we just do game.support enumeration, open and close the brackets. Now that's defined this EQs, and let's just take a look at what the type of EQs is. It's a generator. So generator is a very clever Python construct that essentially contains all the instructions for generating things. So what we can then do is go for eq in eqs, print eq, for example. And then we see there's only one Nash equilibria for this particular game, which is the first player to play 2/3 a third, and the second player to play 0 1/3 2/3. We can, of course, if we wanted to so now if I wanted to run that code again, nothing comes out, because that's what a generator does. It essentially stores the instructions for generating things. So once they've gone through, they're done. So I'm going to define that again. And one thing we can do is we can go list of EQs, and we could save that in a variable if we wanted to, but that just gives us an object that's already there. And if we had a different game that had multiple equilibria, there would be more of these in there. So that's one way of enumerating equilibria using NashPy.